this video we're going to go over simple probability. Now, probability is a chance that an event or something will occur. It can be written as a fraction, but it can also be written as a percent. So the probability of something happening, the closer it's to 0, it's less likely to happen. The closer it is to 1, the more likely it's to happen. If it's a 1, that's like 100% chance of it happening. If it's a 0, it's a 0% chance. If it's 1/2, that could be translated into a 50% chance of it happening. On all these problems, we're going to write the probability as a fraction. Now, there are two types of simple probability. There's theoretical and experimental. In these problems, we're going to go over theoretical probability. Theoretical probability is what you think should happen if all the outcomes have a equally likely chance to occur. And this type of probability can be written like this. So this P represents find the probability of this happening. This is the number of times that could happen, what you want to happen, divided by the possible number of outcomes. I'm going to go over some simple examples, but there's no way I can go over every possible example. What I'm going to go over are the basics. I'm going to use this example as a basic example, and from this point on, you're going to have to figure it out based on the number of cards, a spinner, number of marbles, things of that nature. What I'm going to simply use right here at the beginning is the example of a 6-sided die. Now what they'll do is they'll set up the situation, and like I said, the situation could have cards, it could have marbles, it could be a spinner, it could talk about letters, vowels, anything like that. They set up the situation, they give you the picture, and then they want you to find the probability of something happening. So in this situation, we've got a 6-sided die, and they want to know what's the probability of rolling a 4 on this 6-sided dice. The first thing you need to do is figure out all the favorable outcomes. They're wanting you to find the probability of rolling a 4. So the first thing you need to do is find the number of favorable outcomes. You need to look at the dice and see how many 4s there are on this dice. And on this dice, there's only one 4. So the number of favorable outcomes, the only 4 on this is that one 4 right there. So the number of favorable outcomes is 1. You're not going to write down 4. This isn't the number you're looking for. It's how many 4s are on this dice. If it's red marbles, you're going to write down how many red marbles there are. If it's black cards, you're going to write down how many black cards there are. Then you need to write down the number of possible outcomes. What are all the possibilities I could get on this 6-sided dice? Well, I could get a 1, a 2, a 3, a 4, a 5, or a 6. And what I do is I write down the number of possible outcomes. So the number of possible outcomes is 6. That's how many possible outcomes there are. So the probability of taking this dice and rolling a 4 is 1/6. So let's do another example. Find the probability of using a 6-sided die, and let's find the probability of each one of these. So here's the first one. What's the probability of rolling a 6? Well, how many 6s are on this 6-sided dice? There's only one 6. And how many numbers are on there? There's 6 of them. So the probability of rolling a 6 is 1/6. The probability of rolling an even number. So what I need to do is I need to figure out which numbers on a 6-sided dice. I've got a 1, a 2, a 3, a 4, a 5, and a 6. I need to figure out which ones of these are even. 2 is even, 4 is even, and 6 is even. How many of those are there? There's 3 of them. And how many total numbers do I have? I've got 6 total numbers. All fractions need to be written in lowest terms. When I reduce that, it's 1/2. There's a 50% chance of me rolling an even number on a 6-sided dice. The probability of rolling a 2 or a 5. So again, I need to look at all the possibilities. 1, 2, 3, 4, 5, 6. I want a 2 or a 5. Those are the number of favorable outcomes. 2. Out of the total that I have there, there's a total of 6. And when I reduce that, I get 1/3. So you take the total number of favorable outcomes, you put it in the top, and the total number of whatever it is in the bottom. In this case, numbers on a 6-sided dice. I need the probability of me taking the 6-sided dice and rolling a number. 1, 2, 3, 4, 5, and 6. Every single one of those is a number. So what's a favorable outcome? Anything I roll. How many total are there? 6. 6 divided by 6 is 1. It's a 100% chance for me taking this die and rolling a number. Probability of rolling a 7. Well, this 6-sided dice has a 1, 2, 3, 4, 5, or a 6. Are there any 7s? There are no 7s out of a total of 6. So there's a 0% chance of me rolling a 7 on a 6-sided dice. So again, they could use cards, they could use marbles, they could use a spinner. It doesn't matter what they use. You take the number of favorable outcomes and divide it by the total possible things that are there. This is an 8-sided dice. What's the probability of rolling a 2 on an 8-sided dice? On an 8-sided dice, you could have a 1, a 2, a 3, a 4, a 5, a 6, a 7, or an 8. How many of those is a 2? That 1 right there. 1 out of the total number, 8. 1, 8. The probability of a 2 or an 8. So there's a 2 and there's an 8. There's 2 favorable outcomes divided by the total number, and I always put this in lowest terms. Make sure you read the directions carefully on these. This is a number less than 5. So 1, 2, 3, 4, 5, 6, 7, 8. I'm going to circle all the numbers that are less than 5. That would be 1, 2, 3, and 4. Those are all the numbers that are less than 5. There are 4 favorable outcomes out of the total number 8, and that reduces to 1/2. The ones that are not 3, I've got a 1, a 2, a 3, a 4, a 5, a 6, a 7, and an 8. I need to circle all the ones that are not 3. All those are favorable outcomes. That would be a total of 7 favorable outcomes. Out of the total number, 7 8s. So again, it doesn't matter. It doesn't matter if they are dealing with cards, a spinner, marbles, cars, chairs. It doesn't matter. You take the information they give you. This could be 3 red of anything, 6 blue of anything, 2 yellow of anything, and 1 green of anything. And we're going to find the probability of each one of these. The probability of getting a red one. Well, how many red are there? There's 3. Out of how many total? What I do is I add all these up. I've got 3 plus 6 plus 2 plus 1, because that's how many total there are. 3 plus 6 is 9, plus 2 is 11, plus 1 is 12. There's 12 total there. Reduce that to 1/4. How many are not blue? This is how many are blue. There's 6 of them that's blue. That means I add up the rest of these. 3 plus 2 is 5, plus 1 is 6. There's a total of 6 that are not blue out of the total of 12 that there are. I reduce this to 1/2. What's the probability of getting a red one, a blue one, or a green one? I take the red, which is 3, the blue, which is 6, the green, which is 1. I add all that up. 3 plus 6 is 9, plus 1 is a total of 10 out of the 12 possible, and I always reduce this. So to find the probability, you simply divide. You take the favorable outcomes and put it in the top, and the total that there are in the bottom, regardless of what type of problem they give you.